Hello, welcome back to the channel. In this video we are going to look at the understanding of different functions, or basically the equations of all the different functions. Firstly, we have the linear functions. Okay, so with linear functions, the basic equation, like we said before, is just y equals to mx plus c. Some they usually write it in terms of these other variables, ax plus q. Okay, this is the very same equation as you can see. So when m and or maybe a, I can just say or a, it's greater than when m or a is greater than 0, you'll have the graph looking like this. It's only slanted to the right. But if m or a in each of these equations is less than 0, then you'll have your graph slanted to the left, just like that. And then in each equation, what you need to know, in each graph rather, the q or the c is the y-intercept. This is the c. Okay, so I'm just gonna indicate it like that, and then you are fine. The m, or which is the gradient or the slope, only determines whether the graph is slanted to the left or to the right. But the q or the c, it's your y-intercept, because when you get the y-intercept, you let x be 0, and at that point where this line intersects with the y-axis, your x is always going to be equal to 0. Okay, and then the second one, the second type of a function that we look at is quadratic or parabolic. Quadratic or parabolic function. Okay, with quadratic and parabolic functions, the equations that you have, it's this one of y equals to ax squared plus bx plus c. You also have this equation y equals to a into x minus x1, x minus x2, and then lastly you have the equation y equals to a into x minus p all squared plus q. Some they write this as a plus here, so don't worry too much about that. The plus or the minus only tells you whether the graph, or the original graph rather, has been shifted to the left or to the right. Then you keep it moving. So with this equation, in any of this equation, if a is greater than 0, meaning it's positive, the graph is just going to face up like that. Again, and then you'll still have your graph looking like that, and then you have your xy plane or your Cartesian plane, and then here and there you have your x1 and your x2, and then you have your y-axis or your y-intercept rather, which is the value of c, and then you have your turning point, which is the p and the q. Okay, those are the coordinates of the turning point. And if a happens to be less than 0, the graph is just facing down. Similar graph or the same graph, but just faces downwards. And then you still have your Cartesian plane looking like that and like that. Okay, so that point is still going to be your c, and then you're going to have your turning point here again, which still has the coordinates of p and q, and then you still have your x1, x2 and x1 like that. And then that's pretty much how it's gonna look. And in the case of number 3, in the case of hyperbolic functions, okay, you have only one equation there, which is y equals to a over x minus p plus q. Again, in terms of p, don't worry, it just shows whether the original graph was shifted to the left or to the right. So it can be a plus or a minus there. Okay. How the graph looks is that when a is greater than 0, the graph is going to look like this. Okay, I'm just drawing it. quickly. Okay, here is going to be your horizontal asymptote, and then because it is at minus there, minus p, then the vertical asymptote is shifted to the right. Okay, so it's going to be looking like that, and then it's going to be the other part, and then that is going to be the other part, as you can see. And then if your a happens to be less than 0, what is happening now is that your graph is no longer in the first and the third quadrant, but it is actually in the second as well as the fourth quadrant, just like this and like this. Okay, yeah, that's basically what you need to take from here. And also, let's label this is going to be your P, not the Q. It's going to be your P, which is that value there, and then this one is going to be your Q. And then the equations for the asymptote is y equals to Q and x equals to P, like that. Q and P. So I hope you see. And then you have your okay, there's nothing more to put there. There's going to be a P, there's going to be a Q. And then you have the equations for the asymptotes, y equals to Q, and the whole vertical asymptote, x equals to P. I think it is clear which variable stands for what and which variable affects the graph in which way. So once you understand that, you are fine. For now, that's basically what I wanted you to understand. And then lastly, we have the last function, which is number 4, and that is exponential. Remember, exponential can also be regarded as geometric function. So with exponential and geometric function, you have the equation, which is only one equation. I mean, it's usually in only one format, minus p plus q, just like that. So when you have it like this, also again, here they can put a plus or a minus. Even here they can put a plus or a minus. It just shows where the transformation of the original graph. Is it up, left, down, or up, left, down, or to the right? One of the four rather. But when it comes to exponential, when a is greater than 0, exponentials only have one asymptote, which is the horizontal asymptote. So when it comes to exponentials, the horizontal asymptote, it's shifted from the x-axis upwards like this if the q is positive, so that value there becomes the value of q. So the equation of this asymptote is y equals to q. And then because this graph, I mean the a it's greater than 0, the graph is going to be above the asymptote, the horizontal asymptote. So it's either going to be this here, or it's going to be that pink one. Okay, so which one it is, it really just depends on the value of b. So it's the green one if b is greater than 1. Then if b is between 0 and 1, then it is the pink one. Okay, and I hope that makes sense. So if a happens to be less than 0, you're going to have similar graphs, or pretty much similar, but they're just being reflected about the horizontal asymptote. Okay, just gonna show that quickly. Or maybe I can just use the same set of x's so that you see the reflection. I think that would be better. So for b still being between b and b still being between 0 and 1, and then the a just changes to happen to be less than just happens to be less than 0. This is going to be that pink one. Okay, I hope now you can see. And then for the greenish one, with b still being greater than 1, it's going to look like this. Okay, I hope the difference, this is still b greater than 1, and then the pink one, b still being between 0 and 1. The only difference is that with the lower ones, a is now less than 0. Okay, I hope you see the different shapes. That's basically what I wanted to highlight in this video. And then I'm going to start now doing examples where we sketch, and then we also maybe calculate certain variables depending on the function that we are given and the type of question that we are given. See you in the next video.